Hi Year 11, this is our second video for the topic of discrete probability distributions. In this video we're going to look at expectation. So far we've looked at what random variables are, and we've looked at discrete and continuous random variables, and then we looked at discrete probability distributions. Now the expected outcome or expectation for the random variable x is the mean result, and that has the Greek letter mu. Here's the formula. It's a little bit daunting. Expected value of x, which is equal to mu, is equal to the sum of, from I equals 1 up to n, of the score multiplied by its probability, or x1 p1 plus x2 p2 plus dot 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 plus xn pn. Let's have a look at an example. What is the expected outcome for a six-sided die? Well, here's our table of values here. We've got the different scores, 1, 2, 3, 4, 5, 6, and the probabilities in each case are 1/6. So we're going to go 1 multiplied by a sixth plus 2 times a sixth plus 3 times a sixth, etc., all the way through. And putting that into the calculator, we get 3.5. So every time I roll a six-sided die, on average, I'm going to roll 3.5. Here's another example. Two boxes contain numbered cards as shown below. The first box has the cards 3, 4, 5, and the second box has the cards 9, 10, 10. Two cards are drawn at random, one from each box. Part A, copy and complete the table below showing all 9 equally likely outcomes. And the first part of the table has been filled in for us. So you can see we could have a 3 and a 9, a 3 and a 10, or a 3 and a 10. So what else could we have? We could have a 4 and a 9, a 4 and a 10, a 4 and a 10. Or we could have a 5 and a 9, a 5 and a 10, and a 5 and a 10. Let S be the sum of the numbers on the two cards. Part B, write down the possible values of S. So summing these numbers, we could get a 12, 13, 13, 13, 14, 14, 14, 15, 15. Now it's not asking us to duplicate those numbers, just to write down all the possible values. So we could get 12, 13, 14, or 15. Part C, find the probability of each value of S. So there's only one way of getting a 12, so the probability that we get a 12 is 1/9. For the 13, there are 1, 2, 3 ways to get a 13. For the 14, there are 1, 2, 3 ways to get a 14. And for the 15, there are 2 ways to get it. So there's our probabilities. Part D, find the expected value of S. So here's our probabilities. All we want to do is multiply our outcome by its related probability and add all of those up. So the expected value of S this time is going to be 12 times 1/9 plus 13 times 3/9 plus 14 times 3/9 plus 15 times 2/9. And in the calculator I get 13.7. Here's a past exam question. The probability distribution table for a discrete random variable x is shown. What is the expected value of x? So again, all we do is 1 times 0.6 plus 2 times 0.3 plus 3 times 0.1. So I've got 0.6 plus 0.6 is 1.2 plus 0.3 is 1.5. So our answer is C. Let's move on. The expected gain from a game is the expected return minus the cost of the game. And a game is considered fair if the expected gain is 0, so you neither win nor lose on average. That is, our expected value is 0. So let's continue with that same example with the cards that we were looking at. S was the sum of the numbers on the two cards. Part E, Anna plays a game where she wins $50 if S is even and loses $30 if S is odd. Anna plays the game 36 times. Find the amount she expects to have at the end of 36 games. All right, so here's our sample space. Remember, there was one way to get 12. There were 3 ways to get 13, 3 ways to get 14, and 2 ways to get 15. Now, she's going to win $50 if S is even. So the 12, the 14 there. Or lose $30 if it's odd. So those ones there. And she's going to play it 36 times. So our expected winnings, let's have a look. 4/9, where did I get that from? 1, 2, 3, 4. So the probability multiplied by her winnings, which is $50, plus 5/9, so 13s and the 15s, multiplied by -30 because she's losing that amount. And we're doing it 36 times. And into the calculator, she's expecting to win $200. Okay, one last example. 2 standard dice are tossed. Let x be the sum of the scores on the 2 dice. Find the probability that x is equal to 6. So we've got a little diagram here to help us. We have the score on the first die and the score on the second die here. So we want the total to be 6. So we could have 5 and 1, 4 and 2, 3 and 3, 2 and 4, or 1 and 5. So altogether we have 5 out of 36 possibilities. Find the probability that x is greater than 6. So that's all of these here. If we add those all up, we have 21 out of 36. And finally, find the probability that x is less than 6. So that's all of these ones here. Or we could do 1, take away these 2. But either way, we end up with 10 out of 36. Elena plays a game where she tosses 2 dice. If the sum is 6, she wins 3 points. If the sum is greater than 6, she wins 1 point. If the sum is less than 6, she loses k points. Find the value of k for which the game is fair. So we're going to multiply the probabilities that we just worked out by the outcome in each case and add them up. And if the game is fair, it's going to total 0. So we get our expected value is going to be 5 out of 36 times 3 points, she's winning, plus 21 out of 36 times 1 point, plus 10 out of 36 times -k. And this has to equal 0. All we have to do is solve this equation. So taking the 36s over the other side, we end up with 15 plus 21, take 10k equals 0. It's pretty easy to solve. 10k is equal to 36, and so k is equal to 36 over 10, or 3.6. Okay, that's it for this lesson. Our last lesson for this topic is on variance.